we didn't cover some to cover that day. But here is a great opportunity since you signed into Yaaka and you subscribed, then you have an opportunity to even understand this better. So thank you for subscribing to Yaaka. It's a great opportunity for us to continue learning amidst these hard times. And I hope this opportunity that you've signed up for will take you a step ahead compared to the rest of your colleagues. I hope you take it seriously, and I hope that it'll help you learn a couple of things and apply them once tasked. Okay, so good job for joining. Now today we shall continue with more concept. Since last time we had disruptions, hopefully this time we'll have none. And let's talk about more concept. The last time we met, we were here. We had covered a little bit in front, but I wanted us to go back to remind ourselves of these things. Okay. Okay. So here we have our equation, an equation given you a ratio in which chemicals react and are formed, need to be balanced in order to do calculations. So like we said when we were starting more concept, that one of the skills you have to have is actually the ability to balance equations and just doing mathematical formula. So we have an equation here which is well balanced. If it wasn't balanced, we would calculate and get wrong figures. But as you can see, it's well balanced. We have one calcium this side, one carbon this side, three oxygen atoms, and then two chloride atoms, and then two chloride atoms. Okay. So balancing equations is key. And it will help us get the correct figures that we need. Now, for example, if you have such kind of equation and you're tasked to calculate the... Someone has just joined and they have opened their... Okay. Their volume was on. And you're tasked to calculate the relative molecular mass of calcium carbonate. We said you just substitute in for the relative atomic masses of each atom in here. For calcium, it is 40. For carbon, it is 12. And oxygen, we have 3 atoms. Therefore, it will be 3 multiplied by 16, which is its relative atomic mass. And the total would be 100. Okay. Now, this would mean that the mass of 1 mole of calcium carbonate would weigh 100 grams. That's what it means. And then if you're tasked to calculate what the number of, or what does 0.1 molar of HCl mean? Yeah, this one is just the meaning. If you're tasked to identify what that means, it is just the concentration of HCl. We can always have the unit as molar or mole per decimeters cubed. This decimeters cubed is key because it helps us to understand why we're getting, and we shall see that in a step or two. How many moles of HCl are in 20 cubic centimeters of 0.1 molar HCl. As you can see, the volume we have been given is in centimeters cubed. But we see that our molarity or concentration can also be defined as mole per decimeters cubed. So it is decimeters cubed. Therefore, it is important for us to convert our, when you're calculating moles, to convert our centimeters cubed to decimeters cubed. Therefore, in our formula, as we have seen previously in our triangle, it will be moles times volume, but our volume, the 20, has to be converted to decimeters cubed. Therefore, we divide by 1,000 to get 0.002 moles. That's how we can calculate moles. Okay, we have seen this before. I'm just repeating for us to be able to understand where each of these comes from. Okay. So, if you asked how many moles of calcium carbonate will react, this is where the mole ratio comes in. Okay, the mole ratio. Remember, the mole ratio, you have to have it after balancing. If your equation is not balanced, your mole ratio would be wrong. So you have to have a balanced equation. In our equation here, we see that 1 mole of calcium carbonate has to react with 2 moles of HCl. Okay, 1 mole of calcium carbonate has to react with 2 moles of HCl. We have the moles of HCl already. We have gotten them, they're here. Okay. So this means that for us to get the moles of calcium carbonate that react, we have to half or divide by 2. You can say half the moles of HCl that react. So therefore, you get your half multiplied by the moles of HCl to give you the moles of calcium carbonate that reacted. Okay, that is the use of mole ratio. So now we have the moles of calcium carbonate that reacted. If you're tasked to moles of calcium carbonate, we already saw the mass of 1 mole of calcium carbonate is this. Okay, so the mass of calcium carbonate of 1 mole of calcium carbonate is 100 grams. Now they're asking us, what about the mass contained in 0.001 moles of calcium carbonate? Okay, remember mass will always equal to moles multiplied by molar mass. We have seen this formula in one of our triangles previously. So that would mean 0.001 multiplied by 100, which is our mass here, to give us 0.1 grams. That would be the mass of the 0.01 moles of calcium carbonate. If you're tasked to find the mass of carbon dioxide that is produced, again, here, you can equate the moles of carbon dioxide to be equal to the moles of calcium carbonate that react. Therefore, moles of carbon dioxide that reacted, that was produced, the same as the moles of calcium carbonate, which we found in the 5th step using the mole ratio. Now, remember, the mass that we are finding of carbon dioxide, the formula is also here, moles times molar mass. So the moles, we have found them to be this. Okay, the molar mass for carbon dioxide is 44. It is 12 plus 16 times 2, which gives you 44. The answer would be 0.044 grams of carbon dioxide were produced. So that's just a summary of some of the things we can be tasked to calculate. Do you have any questions on this one? something you have not understood on how to calculate, or something that is still confusing you about these moles? So these are like the fundamental calculations about moles. Some of the simplest calculations. If you understand this, if you understand this slide here, then the next slides will be even way easier. The next types of calculations in moles will be way easier. Okay, because these are the fundamentals. Okay, if you don't have any questions, let's move on. We can look at these formulas on calculating moles of solutes in a solution. So we know that the formula for moles is equivalent to concentration multiplied by volume. You can make each of these a subject to find the other formulas, and we can see that here in our triangle. Remember, we said you just have to cover what you find. For example, if you're tasked to find concentration, it would be moles over volume. Okay. Then if you're tasked to find volume, it will be moles divided by concentration. Then if you're tasked to find moles, again, it will be concentration times volume. So that's how we use that triangle. This triangle should always be at the back of your mind every time you're calculating. We had the first triangle, if you remember it. This is the second one now. Okay, this one involves volume. All right. The other one involves moles, molarity, and then molar mass. So the units for concentration is moles per decimeters cubed. The volume is always supposed to be in decimeters cubed. You'll find that they always give us volume in centimeters cubed, and we always have to divide or multiply by 1000 depending on what we are finding. Okay, it's important to remember this. So the concentration, that is, the moles will be concentration times volume. We have the units in the brackets for us to remember. And if, this is what I was speaking about, if the volume is given in centimeters cubed, then we divide by 1000. We divide our volume by 1000. Okay, this helps us convert the centimeters cubed to the decimeters cubed that are supposed to be. So this is what we do. Therefore, here moles would be concentration times volume over 1000. That's where the 1000 comes from. Okay. Any questions about these formulas? Something you have not understood? You can always raise up your hand and ask if you have not understood something here. All right, let's look at the right way to measure volumes. So, for example, calculating the number of moles in a solid or in a solution, concentration of a solution in a graduated flask, and then volume pipetted into the conical flask. So, for example, you're in the laboratory, you're always tasked to pipette from 250 cubic centimeters into a conical flask. Okay, then you can be tasked to put this pipetted volume into this graduated flask and then fill up to the brim. Okay, it's important to know how to do this correctly. So the original solution has concentration of, like you see here, we've been given the concentration as 0.1 molar or moles per decimeters cubed. That's the original concentration. Moles in 1 centimeters cubed would be the concentration multiplied by the 1000, because we are looking in centimeters cubed. So the 1000 helps us here. Okay. Now, if you asked what about the moles, this would be divided by, sorry, not multiply, to be divided by because you're converting to decimeters cubed. And then if you ask the moles in 25 cubic centimeters, the moles in what you pipetted here, okay, the number of units, or we call them moles, in what you have pipetted, then there would be the volume times the concentration. Okay, remember we are dividing by 1000. So that's it. You'd get this number here, 2.5 times 10 power negative 3 after calculating. Those would be the moles in this. Okay, remember when you pipette, the number of moles change because you have removed a certain volume. Okay, the number of moles are relative to volume. So the number of moles found here won't be the same as the ones found here. And it is proved by this calculation. Do you guys have any questions about this? Nolan, do you have a question? Okay. So I hope this is understood. When you pipette something, the number of moles change because you have pipetted into this. All right. The volume has changed, the moles also have to change. Just like you've seen in the previous slide that number of moles is relative or is in relation to the volume. Okay. So let's try to calculate the number of moles in sodium hydroxide. 25 cubic centimeters of 2 molar sodium hydroxide. Who can tell us what would be our first step here? If we were to calculate the number of moles of sodium hydroxide in 25 cubic centimeters of 2 molar sodium hydroxide. What would be our first step? What do we do here in this question? You can explain to us. We are calculating the number of moles of sodium hydroxide in 25 cubic centimeters of 2 molar of this sodium hydroxide. Who knows? Who knows what we can do? You can even use first principles, it's okay. Who wants to try? Hope? Who wants to try? Peter, do you want to try? Shreya, do you want to try? Guys, you're too quiet. Who wants to try? It's okay, just try and tell us what we'll do first or what you understand by this question. You can always unmute if you want to say something. Someone has typed in the chat box. Trying to calculate. You're trying to calculate on the in the book. I just want you to explain exactly what we can do here, or try to explain what we are required of in this question. So here we are going to just try to to substitute in our formula that we have looked at. Okay, we're looking for moles, right? And we have seen that moles is equal to the concentration multiplied by the volume. Our volume is given in centimeters cubed, so it is incumbent of us to divide by 1,000 cubic centimeters. Okay, and that would give us 2, which is our concentration, multiplied by 25 divided by 1,000. Okay, and then that would give us 0.05 moles. That will be the answer. Yes, hope that is correct. So you were calculating down there. You didn't raise your hand to talk, instead you started calculating. Okay, good job. So that would be the answer. These are the easiest ways. Remember, for me, I told you I'm going to teach you the easiest ways to calculate moles, so that even when the question comes in objectives, you can easily know the answer by just looking at the expression, the mathematical expression. Okay, because now we have the formulas, right? So you don't have to go back to first principles and take a lot of time there. You already have the formulas. Okay, we are cheating now. We are giving you the cheat codes for molarity. Those are nice cheat codes. Okay, we have another question here. What volume of 0.1 molar sulfuric acid contains 0.02 moles? So we are being asked for volume, right? We have concentration and we have the number of moles. Okay, so if you go to our triangle and cover volume, right, and substitute in, what do you get? What do you get? Or what do you do here? Who would love to try? Yes, Hope.
Like if we go to our triangle and we cover up volume, the formula will be volume equals to moles over concentration.
Okay, so we have moles over concentration, which is right there. Okay, that is very good. So that would give us 20 as our volume. Remember the conversion. Okay, here we are looking at they're both in decimeters cubed, because we have moles and molarity. So you can just go ahead and divide 0.002 over 0.1. The answer you get here should be in decimeters cubed. But if you want it in cubic centimeters, then you have to multiply by this 1,000. This is why I put here that we are getting volume in cubic centimeters. So if it is in cubic centimeters, remember to multiply by 1,000. Like we saw in the introduction of the formula, okay? You have to multiply by that 1,000 for us to get it in cubic centimeters. If we're required to get it in decimeters cubed, there is no need for the multiplication of 1,000. You just divide your moles divided by the concentration. Okay, you'll get the answer in only decimeters cubed. So that's it. That is the calculation. Is there any confusion here? Are you guys confused, or you've understood what I've done there?
Like teacher, if we are finding the volume, are we supposed like to multiply 1,000? Like, is it a must?
Like I've explained, it depends on how you want to find that volume. If you want it in centimeters cubed, okay, that's a very good question. If you want it in centimeters cubed, you have to multiply by 1,000, because that helps you convert these decimeters cubed into centimeters cubed. So by multiplying it on the above here, you're sort of converting this into centimeters cubed. If you're required only to find it in decimeters cubed, there's no need to multiply this 1,000. So therefore, the answer you'd get here would be in decimeters cubed if you didn't multiply by 1000. Okay, we saw it here. Let me go back a little bit. Because in most cases, this confuses students. They think we multiply by 1000 for the sake of it, okay, which is not true. It doesn't come out of nowhere. Okay, let me see. I think it is right here. Okay, so as you can see, in our formula here, we started with this formula. Remember here now we're starting with looking for moles, but if we started with, if we were to start with volume, it wouldn't make any change. But let us use this. We are finding moles. Moles are equal to concentration times volume, right? But that would be only true if the volume we are finding is in decimeters cubed. Okay, there is no any 1000 here in this formula. Okay, you can even see it. No 1000, because the volume we are finding is in decimeters cubed, and the molarity we have is also in decimeters cubed. Does that make sense? So there is no need to convert anything, right? No need to convert. Okay, so this is the standard. But look here, you have molarity in decimeters cubed, but your volume is in centimeters cubed. We can't have this disparity here. This is not allowed. We can't have this. You either convert the centimeters cubed to decimeters cubed or the decimeters cubed to centimeters cubed, depending on what you want. But in this case, we want moles. Our moles should always and always be in decimeters cubed because they relate to the concentration, they relate to molarity. Okay, so for the moles, in case you're finding them, you always have to involve 1000. Okay, the moles. Okay, because for them we have to relate them to our concentration. Therefore, when you're finding these moles, you're going to find your concentration, multiply it by the volume. Make sure that the volume is divided by 1000 to convert it to the centimeters cubed now in this case. Okay, we're finding it in centimeters cubed. So we need to convert, not into the centimeters cubed, into the decimeters cubed. Like I said, we have to relate our moles with our concentration. So by dividing the centimeters cubed by 1000, you have converted them to decimeters cubed. Okay, that's it here. Same thing if we made volume the subject. If we made volume the subject, we would have moles divided by concentration, our concentration. Okay. But if we are to find our volume, by in decimeters cubed, there is no need for us to convert or use 1000 because our concentration is in decimeters cubed and our moles are always just mole. Okay, so that is fine. But if we want to find it in centimeters cubed, then we have to involve the 1000. How do we involve the 1000? We multiply it by this, or our answer. Okay, we multiply it by our fraction here, moles over concentration times our 1000. Okay, and so we'd have here times 1000. Okay, if we were finding it in centimeters cubed. So that's the explanation. Okay, not cramming that always 1000 is involved. Where it comes from is when you're converting from decimeters cubed to centimeters cubed, or from centimeters cubed to decimeters cubed. That's where the 1000 comes in. Does that make sense, Hope, now?
Yes, teacher.
Okay, good job. That was a good question for me to explain. Awesome. So that's why we have our answer here as 20 centimeters cubed. It is because we have converted it into centimeters cubed by multiplying by 1,000 here. So answer. Okay, so this is it. That's the calculation I wanted us to go through to remind ourselves not to forget. Okay, that's what I wanted to go through, not to forget. Last time, I gave you an activity. But I don't think anyone here did. Hope, did you do it? I think I only received like 2 people who did it. Okay. And I don't know if anyone here is a Mag. Hope, did you do it?
She gave us the activity.
Hmm? You never saw it. So, Peter and Shreya, you guys need to do this activity. I'm going to send it. You guys need to do it, okay? In fact, the people who did it have not even subscribed yet. Hopefully, they are going to subscribe this week. Okay, so I'm going to send it right now, and you start doing it right now. Is that okay with all of you?
Yes, teacher.
Okay, good. So remember, the way we are going to study is not going to change much. In most cases, I'll be sending out activities first, so that when you do them, you come to class, I teach for some time, then you present your activities. Or you present your activities first, then I teach something new or something, or I explain the activity on how you have performed. Okay, that's the way we're going to be doing it. I'm going to avail you all the links to our courses. I hope those ones have been provided already, but if they have not, I'll show you the sum of the units. I'll give you the links to the units that I want us to cover, so that you can always go through on your pace. And when you come to class, you already have questions. For me, I enjoy questions. Science is all about questions. The more you ask questions, the more you understand. Okay, so when you come with a lot of questions, you make your learning easier. You learn more when you have questions. So I'll be sending out activities first with the link to the unit. You go through, you do the activity, you come to class, and then present. And then I also teach something new, like I've been doing in the past 3 weeks. And then we'll continue like that, okay? I'll be sending you, in those units, you'll see interactive activities, you'll see videos and all that, all right? And if I have additional information, I always send it. Okay, because now you have access to the entire package. You need to maximize. All right. And I'll try to teach you more often. I'm going to use this week to see my timetable, how it will work. And then I can see how many lessons I can put for you. Because you guys remember, when you're in senior 6, you only have 2 years to cover content that you should cover in 4 years. So it is important for us to wait, this is senior 3, right? Yeah, this is senior 3, my bad. So you're in senior 3, and you guys are going to do exams probably next year. So you have a few months left. So you need to cover a lot. Therefore, I will send you these links to the units that I want you to cover. And then you guys will be doing those activities, and you'll be presenting, and it will be fun. I'm excited to see how you're going to learn. And and change on some occasions. So now I have told you accountable. I'm going to be very hard on you on the activities. For that one, it's going to be neck on neck. So make sure you do this activity that I'm going to send out. Do it, submit. You can submit on my email. Okay, take pictures, submit on my email or in my WhatsApp inbox. Does that make sense for everyone?
Yes.
Teacher Solomon?
Yes, please.
Can I show something where they can also interact with you?
Yeah, go ahead. Let me stop sharing here.
Okay. Okay, is my screen clear?
Yeah.
So here I said I can go to the dark mode or light mode. It depends on what you want. So members, if you do an assignment, like a user class activity, not the assignment in the system, you can come under messages. When you touch on messages, you come here and say new message. You're seeing? So when you tap a new message, you can come here and search for your teacher. Say Solomon. And Teacher Solomon, which one is this?
Probably the capital one, I guess.
Okay, so you tap that one. Then you can come and write here is the message. I think should go away. Okay, so here is the message. You can say maybe assignment or class activity, something like that. Class activity. Then you come here and write the message board and say, good afternoon, teacher. Here is the activity you gave us. So from here, you can click around here. You use the down arrow key on the keyboard. You scroll. So you come here, you get it where it is. You browse it. You attach it. Where did it go? Sorry. Let me repeat it. Back there. What has happened to the ecosystem? So let me go back and get a new message. So okay. Done. I'm done. Activity 6. So scroll down. So here you browse it. Don't know why it is disappearing for now, but this is the system we have been interacting. You can see me, I've been interacting with my learner here every time. Let me go back slightly. You never know with internet. But I implore you to start using it. Teacher Solomon, could you share your screen if you could do it briefly for them?
Yeah, but I don't have the browser open, but I can try. I don't know. Let's see if we can try. We still have time, so let me try. Let me see.
Okay. I had opened my account as a student actually. So let me open as a student here. The other side, I was an admin person. Here I'm a student, so I come to messages.
No, share again. You're not sharing right now. Are you sharing? Let me see. No, you're sharing.
Okay. So here, yes, this is part of the student. So I compose. I search for Solomon again. Oh. Okay. So if I've chosen,
you've chosen all of us, huh?
It is okay. I don't know which one is which, but we shall know who is Teacher Solomon. Huh?
Yeah.
So activity done. Then I teacher done activity 56. Find it attached.
Before you do enter, you have to attach.
I pressed enter. I pressed enter. I pressed enter knowing that I'm going to another line. Okay, maybe let's begin with attachment. Let's begin with attachment. So here it is saying upload. So here I upload. Maybe you had saved your work on the desktop, so you can browse for it. Maybe it is called assignment 1. So it is there. You can now write my message. Hi, teacher. Done. Assignment. So here, subject, chemistry. Tuesday. Then the member, you search for the member. Solomon. When it comes, choose. And also choose that one. Then here you can now send. It's just hidden here. It is just here. You tap on send, and message has gone. To check, you can check under sent. You see that I sent the message. This is the one we just now. So even if the teacher marks your marks, you will still get them under inbox. You'll find your marks there. And more to that, you can still show some functionalities. This is where we shall be setting your Zoom links. If they are for a certain subject, chemistry, you will find them under course. If it is a group of chemistry discussion, we can put there. If it is a general class, it can be under shared. Maybe we have a meeting from senior 1 to senior 6, it can be located under shared. And then in case you're doing your chemistry, I don't know whether I'm attached to chemistry, maybe let me use this biology senior 2.
I have it there.
Yeah, if I start senior 2, maybe biology, and I would like to do commenting, so I can tap around there. I can add a comment. Hi, teacher. The picture and transport animals or in plants was not clear. Maybe that is a comment. Or you're saying, teacher, can't we have an alternative to this? Something like that. That is a comment you added. The teacher will be able to see, and it is from who, that student, Benny. Then you can ask a question and maybe say, I need more questions on this. May I have more questions on this topic? Something like that. You ask a question. So the teacher will be able to see that this was a comment, this was a question. So let's interact with our system, and we embrace it very well and interact in every situation. So you see, you have to continue answering your assignments, even these ones that are interactive, and then continue to submit. Continue to submit those assignments. I'm scrolling to the bottom. So here you can attempt that assignment. Yes, Hope, your hand is up. So here it says that describe. Yes.
Like I have a question.
Yes.
Like okay, the previous there where like after logging in, like where do you go to find this thing on the left? On the left, okay, where there is my courses, message, links, the things like that. That like where do you press?
Okay. So here you see this assignment. You can attempt it using all these file types. You can answer in a Word document, a PDF. You can answer in your book and take pictures. You come start assignment, you upload that file which you have saved. So those are a few functionalities. We shall keep interacting more and more. Let me help Hope in these 3 minutes. So Hope, I'm now closing this. Can you see my screen?
Yeah.
So here, I will go to yaaka.cc. I press enter. So when I press enter, the page will load. This one also depends on your internet, how fast it is. So once it has loaded, you now scroll down. Actually, I'm already logged in. So it might take me directly to my courses because I'm already logged in. Let's wait and see how it will behave. It might take me directly.
No, now you have to go to courses.
So in case it delays, you can reload. Because you see up here, I'm logged in, even at the bottom, I'm logged in.
Yeah.
So Teacher Solomon, Hope has been disturbing me since morning. Hey.
How to this, eh? That's good, that's good. She's very active.
I organized like 3 sessions for her. She was logging in. Okay, so in case it disturbs here, at times you can come here and add the word welcome. Something like that, you press enter. Even my system here is overloaded. I'm having a lot of pages running. So when you put that word welcome, I think it should be able to take you directly. Have you seen that, Hope? You see that one? Hope?
Yes.
Yes, just yaaka.cc/welcome. You do this when you know that you have checked up and down you are logged in. So from here, you can go my courses. You can check if the teacher has marked your work and you have some messages. You can even chat with your colleagues, those you know that they are in the same class. You get? So when you get marks, it will be like this. You have obtained 17 out of 20 in activity of integration chapter 1, additional marks. Well done, go to next chapter, something like that. So hope go and try out and see how
everyone go. Everyone who is going to do the assignment, everyone is going to do it. If you do it, when you're done, submit like that, okay?
Okay.
Don't submit to my email box, try out this method and submit
yeah,
to
actually,
me.
the email, once they send mails, your message box will be full. Let them start using their site. Here, it is even easier in marking and the rest.
Right.
Okay, bye.
Okay,
right.
thank you.
Thank you very much, Mr. Kaku.
Okay, so hope we're going to try
Peter and Shreya will do the assignment, including hope submit like that.
Thank you, teacher.